Hello. It's really exciting to get a chance to talk with you about the Zen of Visual Analysis. My goal in this talk is to talk about the keys to effective visual analysis. First, I'm going to discuss how we think and reason about data, and then I'm going to follow that up by talking about how software can support you in that process, how that process influenced us in the design of our product, and how you can adapt your techniques to better discover the stories in your data. So, how do people reason about data? Typically, software likes to push our thinking into a pipeline process. It assumes that we'll just query for data, calculate the results, and create a picture. But that's assuming that we know precisely what we need before we've even begun the analysis. And this just isn't really how we typically work, right? I mean, not even for simple tasks, like when I booked an airline ticket to the conference. I knew exactly where I wanted to go and when I want to be there and how much I wanted to pay. Yet, I had to engage in this cycle of Q&A with the different airline sites and that, trying to find the right ticket that optimized to my variables. Really, what happens is there's this unpredictable and iterative process of question and answer that involves many tasks. Sometimes it's gaining confidence in our data, discovering structure, finding patterns and outliers, or deriving causal relationships. A lot of it's simply about finding the right view of our data. At Tableau, we call this iterative process the cycle of visual analysis. People typically start with a task or a goal, and then they go searching for the data they need to answer those questions. Some of that data might be in the official data warehouse or in an Excel spreadsheet on their desktop. They collect that data, and then they start looking at ways to look at that data. Is it better to look at it as a bar chart or a heat map or a line series? And as they go through that discovery, searching for visual structure, they often realize, wait, I need more data. I need more data from another Excel spreadsheet, or maybe I filtered to the wrong stuff. And so they go get more data and they create the view again, and then they identify other views they want to look at. And they may develop insight, or they may actually stumble across other more important questions they need to answer. So this cycle of visual analysis isn't about going around this circle in a very organized pipeline process, but rather about jumping back and forth as we engage in this rich question and answer with our data. So that's very abstract. What I'd like to do is actually jump to a demo of Tableau and use it to show how we can do a cycle of visual analysis. And I think that'll make things a lot more concrete. And what I'm going to do is actually I've collected a lot of the expenditure data for the 2000 presidential election campaigns up until I think the end of May. And, you know, as a citizen of the U.S., I'm very interested in how this money is being spent and what are a lot of the variables that affect it, and should I be contributing to the campaigns. And so I really do have sort of a question-answer process I want to go through. So let's switch to Tableau. And so this data comes from the Federal Election Commission, so it's required disclosure. And this data will tell us a lot of things like which candidate it was that spent the money, what city they spent the money in, when they spent the money, how much they spent. And so there's a lot of interesting variables here, and we can start to try and understand this data. One of my first questions would be, well, how much money are we talking about? So I can drag amount out here to the rows, and I can quickly see we're talking about quite a bit of money. It looks like almost $900 million that has gone into just up until the end of May, so this is still really the primary season. And right away I'm going to start to have more questions. It's going to be things like, well, how did this break down across the different candidates? And was the spending different on a party-by-party basis? And so I can just start adding more information to my visualization. I might want to see who the top spenders are, so I'll quickly sort the data. And so now here I can see, well, it looks like the Democrats, you know, particularly Obama and Hillary, have spent considerably more money than the Republicans. And I can see how the front runners compare to the other candidates. But now I might find that I want to ask some questions that aren't well supported by this particular view. I want to change the data and what view I'm looking at. For example, I might be interested in how this spending changed over time. Is most of the money being spent in the recent weeks or earlier in these primary campaigns? And how did that vary by candidate? So I can take time and bring that out here into the view. And I'd really like to look at it sort of at a month level basis. So I'm going to do that. Bring out amount. Now I'm going to start looking at time series because I'm really interested in time varying behavior. And we can see these interesting spikes and valleys as the spending has changed. And we can break that again by candidate. Bring candidate into the view. And here we start to see some really interesting behavior, really across all the candidates. And I can sort these why don't I sort that by the amount spent so I can sort of get the guys at the top? I think I sorted that the wrong way. Let me reverse that. And when we start to look at some of the trends, like we can see here, Hillary Clinton and Obama, really the front-runner spenders, but we can see an interesting time series behavior and how they spent money. We can see this peak that they both went through right around, looks like around February, and then we can see them dropping down in March, and then we can see them peaking again in April. And this is an example where actually we'd probably want to go out and bring even different data, a completely different data set into our analysis. Perhaps the timing of the primaries influence this. Maybe, timing of Super Tuesday or the timing of other candidates dropping out. We can look at people like Mitt Romney here and see how he's been, investing in his campaign and then winding it down as he admits defeat. Or we can look at John McCain and see his investments rising as he fights off to get the nomination, and then see a dip and then a retrenching as he gets ready for the general election. Now, this isn't the only questions I'd want to ask, though. I'd now start to really be interested in, well, what is the geographic spread of this spending? Where is the money being spent? Is it all in the battleground states? So I'm going to switch to another view, and in this case I'm going to create a map because the questions change from one about time or who to a question about where. Where is this money being spent? So I'd really like to look at what state the money is being spent in. So I'll do a quick show me and use our new mapping feature. Let's hide the map options card here, and I'm really actually just going to focus on spending in the continental US. So let's zoom in, and we'll make our marks a little bigger and introduce some transparency. And so now we can see the spending as it varies by state. And we're not surprised to see a lot of spending in the East Coast and some of the battleground states, but I already noticed some interesting things like here, this red dot, that's spending in Colorado. And the question jumps to mind, why are we spending money, or why were the candidates spending money in Colorado? It seems unusual. It's not a battleground state. The primary wasn't particularly controversial. So now I'm starting to uncover new questions I didn't even expect to be asking. Why is money being spent in a particular place? And what I might want to do is go from state level to zip code to see, well, is this dispersed across the state or in a particular zip code? And as we retrieve that data, we see, well, now we've got zip code level, and most zip codes have small dots because not a lot of money was spent there. But we can see that there is a single zip code within Colorado where a lot of money was spent. In fact, if we tooltip over it, $43 million was spent campaigning in 80203. And so now we're going to want to dig into this deeper and understand, well, which candidate spent this money? And so I'll take candidate, and I'll put it on the page shelf, and we can just page through looking at how each candidate's spending was geographically distributed. So here now this page represents Hillary Clinton, we can see on the page shelf. And I can see that she had considerable spending. In fact, it looks like she may have spent all the money in Colorado. I can tab through and look at John Edwards, and, well, his spending, there is one zip code over here in Georgia where a lot of his spending occurred, but otherwise it's fairly distributed. We can tab through Giuliani, McCain, we can see has, a fair bit of spending in zip codes in Maryland and D.C. Barack Obama has a really large spend over here in Pennsylvania, so, it doesn't appear that the reason this spending is occurring for any particular battleground state or anything, because we're in most cases seeing a single candidate spending all the money. So I've actually already created a sheet link so we can dive in and understand this. So I'm going to go from Hillary's expenditure, and this page here is going to show us exactly what money she spent. So I've dived into the details here, and let me just take a little room so we can look at that. And we can see that Hillary Clinton spent $43 million in that zip code with a single firm, Media Strategies and Research. We can see that the type of expense was advertising, and we've answered a question we didn't expect to even ask, which is, well, actually what's happening is the geographic distribution doesn't tell us that much, because what's happening is this is showing where the money is being spent with consulting agencies, and then they're basically acting as intermediaries, and the money is probably dispersed pretty broadly from them into media campaigns and payroll and salary and catering. So really the answer here is we don't have a lot of visibility geographically. The last point I'm going to look at is just who are the top people to receive this money. So I've already created this view, and here we can see the top candidate is GMBB, and that's $84 million spent by Barack Obama, which is really a lot of money. We look at Media Strategies, that's the one we just saw in Colorado for Hillary Clinton. And here I've colored them by candidate, but we can also look at things like the type of expense. And I'm going to sort that descending by the amount spent in each category. And now we can start to look at these expenses. If I use the legend highlighting, you can see really the top expenses really is advertising, media production. I classified all sorts of media buys and print and stuff into this single category. We can see another one of the top categories is bulk email, travel and airfare, payroll and salaries. And then an interesting one, I think is probably more of an emerging thing, phones, internet, and BlackBerries is a large expense for campaigns these days. And so the real point to this was just a sort of a quick look at what types of analysis would we really want to engage in with a data set. We don't often go with a very specific question we can answer with a pre-canned IT-authored report. Instead, what we have is this cycle of analysis where we really want to dive into the data and engage in this ad hoc analysis to understand the data and understand how to look at the data. Now, a really important point I want to make is this isn't just about aha. This isn't about putting on our data mining cap and going spelunking in the data hoping to discover something. It's about the process of engaging with our data and understanding our data. This ad hoc cycle of analysis, it isn't just to find outliers, right? It might be that we're simply trying to validate and understand data. It may be that Jock, the director of visual analysis, may have sent over a spreadsheet that I want to understand before I start making decisions based on it. So I really need to engage in the type of Q&A we just engaged in to understand the data he sent over, to understand the spreadsheet, to gain confidence the data is correct. Or I might be doing this because I really just want to find the right report to author for our CEO, because he called me up and says, well, I want to present to the board last quarter's results, and now I need to make sure that I give him views that really capture the stories of last quarter. If revenue grew, why did revenue grow? I need to get in and understand the data and understand the stories, and then understand the best way to visually convey those stories. I might also just be trying to find the best way to present the discovered results at my next team meeting, or I might be trying to build a dashboard for monitoring, and I might be needing to engage in this Q&A to understand what are the views that will best help me capture and monitor key metrics, and what are the key metrics? I really need to work with the data to discover those. So sometimes it really is about the aha, it is about unexpected discoveries in your data, but the cycle of analysis is also about just that process of working with, understanding, and visually presenting your data. So throughout this talk, I'm going to have little pieces of advice, and these are really my guidance to better engaging in visual analysis with your data. And so my first nugget is just iterate, explore, and experiment regardless of task. Really the point I just made, which is do not reserve this ad hoc analysis, this engaging with your data, for that random occasion where you have an hour to just spelunk. Use this in all cases when you get to know your data, tease your data, build confidence in your data, and find the stories in your data. So now in the second part of the talk, I really want to dive into how can products support being one with your data, and how can I use them effectively. So I really want to talk to what I think are the 4 key aspects that a product needs to do to support visual analysis, and then talk about how we expose those in Tableau and how you can leverage what we've exposed. So the most important thing is the product really needs to support the cycle of visual analysis. And there's 4 things I believe you need to do in a product to support the cycle of visual analysis. The product needs to be incremental, expressive, unified, and direct. And I'm going to talk to each of these. The first is incremental. What do I mean by incremental? I mean that people need to be easily and incrementally able to change their data, how they're looking at it. And what this means is we can't have this templated wizard where we go in and we pick a specific view and then we're locked into that view. Instead, we need to be able to create, as we're showing here in Tableau, I can just create a line chart and then say, well, how does that break down by product? And then how does that break down by type? It's just incrementally layering more and more information into it, bringing more data from the database, or alternately changing the way I'm looking at it, right? We worked very hard within Tableau to make it possible to incrementally change both the view and the data. And why is this so important? Well, I think there's really 3 reasons that it's important to have this incremental capability. The first is to find the perfect view, right? You want to be able to quickly and easily change between views so you can find the right view that answers your specific question. The second is that it allows us to perform this rapid Q&A, right? It allows us to rapidly say, what about this? What about that? And really quickly, rather than have to switch to how will the tool let me do this, we can just be rapid firing these questions at our data and getting answers. Finally, it lets us build visual literacy at our own pace. So I'm going to talk to that a little on this next thing, which is my advice when it comes to starting to look at your data visually or engaging in visual analytics is to start simple. And the way I really like to think about this is by talking about our first customer, Tom Walker, who's now our CFO. I remember when we went out to visit Tom, and he was our first customer. He just bought the software, and Christian and I were driving over, and I was really excited about, on the drive over thing, but what are all the ways he's going to want to look at his data and all these sophisticated views he's going to create. And we got over there, and basically, Tom, with our help, created the views he already had. And, I was trying to understand why this was good, but what happened was he built confidence in the software and the tool by building the views he had, and then slowly over time, he made them more sophisticated, right? The next time we visited him, he'd gone from a text table, and he'd moved a measure onto color, and now he had a text table that highlighted some of the outliers. And then he moved from a text table to a table of bar charts, and then he started creating scatter plots and dashboards and really rich timelines. But it didn't happen on day one. And I realized later that this was really brilliant, that what he had done was he started simple and gotten an immediate success on day one. He didn't, engage in this long process of mapping out and deciding what are all the possible views. Instead, he just started working with the data. And he got views he knew were effective, he created those, and then he incrementally, from those views, constructed more and more sophisticated views, and now he has this amazing collection of views that he uses to monitor all aspects of the Tableau business. The next point I want to make that software needs to do to support the cycle of analysis is to be expressive. And really the point here is that there's no single view for all tasks and all data. If all you have is a hammer, then everything looks like a nail, but what we need is actually a set of views, or the ability to create all sorts of different views that are targeted to different tasks. Right? I remember when I started grad school at Stanford, all the researchers in visualization were really intrigued by creating the ultimate perfect view, right? There was this theory that if we used the right amount of shading and 3D and perspective and tree maps and filters, that one view was going to answer all questions. And one of the key insights I found later was that you really need a collection of views and the ability to move between them to answer all your questions. And we can just start to look at a set of views and think about the questions they support, and I think this starts to become really quickly obvious, right? If I'm interested in how my sales or costs or anything varies over time, well then a timeline or a time series can be extremely effective. But if I'm interested in the geographical disbursement of my data, well then that graph's not going to be effective at all. I really need something like a map. But if I want specific, exactly how much did I sell last quarter, well actually then the text table is the perfect visualization. It's got my numbers and it's got them down to the cents. But if I'm looking for outliers, say in a large collection of data, a heat map might be the best way to understand a really large multidimensional problem and help me find outliers within that multidimensional space. So each of the views we have on this slide here are great views for understanding the data for a particular task. If I'm trying to understand time-varying behavior with a map or with a text table, I'll struggle. But for the right task, the views can be really, really effective. So this leads to another piece of advice, and the advice I have here is to reverse your thinking. The fact that you need different views for different questions really sort of highlights for me the problem with the pipeline that says pick your view and then start asking questions, right? You want to really reverse your thinking and start with the data, right? What data do I want to look at? What questions do I want to answer? And then start trying to find the views that will afford or accommodate that questions. And then move quickly between different sets of views as you work from your data, right? What do I want to see, not how do I want to see it? Try a lot of views so you can find the perfect view. And, advice for using Tableau in this context, if you're not sure what view might help you, try Show Me. It may give you some thought-provoking ideas on how to look at your data for a particular task. The final point I have about supporting the cycle of analysis is unification with the database. Right? A key aspect of reasoning with your data is easily changing the data you're looking at. And if we look at the traditional model for reporting tools or visualization tools, they're really one of two models. Reporting tools have tended to say, well, query the database a whole bunch of times, use a pivot table or a text table, do your query and analysis, and then when you're done, create your view. Right? Well, this really takes the view out of the Q&A loop and makes it simply a presentation tool rather than an analysis tool. And yet we know visualization is extremely powerful and effective for the cycle of analysis. The alternate approach is what visualization tools would say, query once, load it into our data silo, and then iterate via the view. But this is often broken for two reasons. One is it assumes that that first query got all the data I needed, which is often wrong, right? As we've seen in this cycle of analysis, we often discover we need more data than we have, and we need to pull that data in. The other problem here is often they assume a single view, and they just give us simple affordances to filter and sort on that view, where we've also seen that really it's about iteratively changing the data and image to find the perfect view. Another benefit of unifying with the database is it really allows us to leverage the exciting advances in database technology, right? To architect around moving the data from a massively parallel cloud-based database into a desktop silo seems fundamentally wrong, right? Within the database industry, we're seeing exciting stuff like column stores and OLAP and in-memory databases and cloud-based parallelism. And really what we want to do is have our analytics tool be able to push work to these powerful databases when they're available, not move data into a silo. And so we've really focused on making it easy to grab more or less data, but don't move the data. Keep it shared and consistent. The final aspect of supporting the cycle of visual analysis is directness. We really want the tool to disappear. We want to allow the user to be directly interacting with their data, right? Whenever the user has to focus on the tool rather than the task, then they're not thinking about their data and they're not thinking of their problem. They're out of the zone, right? We spend a lot of time trying to make the tool disappear. And you can see when we were doing the demo and looking at the election data, the dialogue wasn't about, and now we launched the wizard to get a bar chart and then we'll create a pie chart and we'll use this template to do that. It was more about the data. How does this break down by time? How does this break down by candidates? What's the spike in my data and is there a geographic distribution? We want the dialogue to be about the data and about how we're looking at the data, not the tool. So we've mentioned these four aspects that are really important to supporting visual analysis, right? The tool being incremental, the tool being expressive and supporting a wide range of views and making it easy to switch between them. The tool being unified with the database so we can easily get more data and also scale to large data. And the tool being direct so that our dialogue is about the data. So how is it possible that Tableau really accommodates these four aspects? Well, it's because we have this secret sauce, something we call VizQL. And what VizQL is, it's a language for graphics or a language for graphical analysis of data, right? We aren't built on a template system. We're built on a language which is a fundamental technical innovation that allows these things like expressiveness, incrementalness, declarative description of graphics. And so what VizQL is a lot like SQL, except it describes graphics. And I look at the world of visualization and visual analytics where most tools ship with 1 or 5 views and ask you to pick from a template. And I think, man, imagine if the database industry had taken this approach. Rather than building a declarative language like SQL, they decided, well, we're going to ship with 5 pre-built queries. You can answer any one of those 5 questions. It's built right in there. You just select it from a menu. Well, we definitely wouldn't see the database industry we see now, right? What you needed for the databases was this expressiveness to, ask your specific business question of the data. This is no different from the visual analytics point of view. And so VizQL is a declarative language that can be composed to express pretty much any query you want on the data, except it returns an interactive picture of your data. And this is the core technology within Tableau. So, continuing this discussion of how do products support being one with your data, well, our first point was supporting the cycle of visual analysis, and that's what we've just spent a fair amount of time talking about. But that alone isn't enough, right? You also need to be able to automatically generate effective views of your data. And the reason for this is we want everybody to be able to engage in this cycle of analysis or cycle of visual analysis with their data. And the people doing this shouldn't have to be graphic designers or psychologists, but at the same time, it's really important that the views that they're working with, the views that the tools generate, are effective, because ineffective views can lead to the wrong conclusions, or they can hide important stories in the data. So how do we balance this? We can't have users being graphic designers or psychologists, but we need to have effective tools, and we need them to be really easy to generate, or effective views, and we need them to be easy to generate, because as we engage in this Q&A, we need to rapidly switch between effective views. The first thing I want to do is talk about what is an effective view, and then what we've done within Tableau to help people generate them. So an effective presentation of data needs to do a number of things. It needs to communicate all the data. I'm going to dive into this point, and I'll say right away, I don't mean communicate every single record in the database. I mean communicate all the data necessary to answer your question. It also needs to communicate only the data. And again, this is only the data relevant to the question being asked, and only the data that really exists. There's a lot of mistakes you can make in visualization to create data or create the perception of data that doesn't actually exist. We want to leverage a human perceptual system so we can quickly see the story in the data and quickly understand the outliers and the patterns. We want to make sure the views we create are understandable so we can talk about them and share them and interpret them. And we want them to be interpretable, and I'm going to dive into that one also and explain a little more what I mean. But let's step through each of these. So communicating all the data, really what I mean is communicating all the relevant data. And I'm going to do this or explain this by showing you 3 pictures of exactly the same data here. Now the question I have is, how has my profit been trending or varying over time? Now to answer that, here's 3 potential graphs, and all these graphs are showing exactly the same data records from the database, right? They're showing profitability by month, by product, or by market. But they're showing in 3 different ways. And I say 2 of these are bad and 1 of them's good, and let me explain why. In the first view, we're not really allowing or communicating all the relevant data. One of the things we're not communicating here is the continuous nature of what we're not communicating here is the fact that in this first chart, where we have a bar chart, we've stacked the points, yet our question was, how is it trending by market over time? And by stacking it, we've actually lost some of the data because each of these blue points doesn't have the same common baseline. So when I start to look at June versus July, I can't even tell if it increased or decreased between these 2 bars because they don't have the same common baseline. So I'm not able to, with this view, start to answer my question, which is, what is the time varying behavior? Because I can't see the time varying behavior. This view isn't communicating all that information. The second view does better because it uses dots, so we can start to see the individual markets and their time trend behavior. But if we look at it, we're not being encouraged to look at it as a time varying trend. Dots suggest a discrete event, and we don't know if we look at dots whether there really is a meaningful relationship between adjacent points. The 2 adjacent points here could be oranges and apples, in which case I can't interpolate. But if it's June and July, I can interpolate because it's a continuous trend. And so this is why the last chart here is actually the most effective, because not only does it communicate the data, but it supports the question we're asking, and so it communicates all the relevant data to the question. It shows the specific data records retrieved from the database, but it also shows them as a common baseline, so we can do the month-to-month comparison, and it shows them as lines so that we're drawn to the continuous nature, and we're drawn to really what is the change between months, not the values in each month, right? The relevant data to our question is the difference between June and July, not the absolute values of June and July. The second point is communicating only the data. So here I have 2 views which are aesthetically great, but subtly flawed in that they encourage us to make sort of perceptual judgments about the data that aren't correct. So here in this line chart, we've got the same line chart as we had before, except we've now used different shades of blue to encode the lines. And the problem here is those blues, they vary in lightness and saturation in a manner that suggests that there's an ordering between the values, that somehow west is more important than south and south is more important than central, and our eye is drawn to the most saturated information, right? It looks like for some reason the author is trying to say the west is most important, and maybe in fact there's some sort of varying behavior between the 4 regions, but they're not. They're just discrete regions, and we should look at them as equal, and unless we have a specific point to make about it. So this graphic has accidentally communicated information that isn't really in our data, which is that the west is more important than central. In this graph, we're using size to communicate sales, but we've made a subtle mistake. Size of the top point here is supposed to represent $96,000, and of the bottom point is supposed to represent $15,000. But then really the size of this circle should just be 6 times larger than the size of this one. But it's many, many, many times larger. And so because the sizing isn't really linearly related to, or the sizing by area isn't linearly related to the value it's encoding, perceptually I see that one point is equating to much, much more sales relative to the smallest than is actually true of the data. So that subtle mistake is communicating information that isn't true of our data. We also want to make sure to leverage the human perceptual system. So again, here we have two graphs communicating exactly the same information. And on one, we're using color, and on one, using size to encode the markets. And now if I ask you a question like, how does profit trend with changes in sales for Central? Well, in this graph here, Central is blue, and our eye can quickly separate blue and see this upward trend. In this graph, Central is represented by the smallest dot, and our visual system isn't built to quickly do separation by size, so we have to sort of manually find all those small points and then try and construct in a serial process the trend they represent. So it's really important that the graphics actually try and use the most perceptually effective encodings first, and for the most important information, and then use other encodings for the secondary information. If we don't do this as we're rapidly engaging in our Q&A, we can easily miss important information. The point about understandability here is that although these two pictures are really intriguing and interesting, I don't know what they're telling me. And so a graphic can be beautiful and aesthetic and compelling, but not understandable. And yet most of the graphics we use in our everyday discussions and Q&A and talking with other people, they appear in PowerPoint slides for 5 minutes up on a projector or viewed quickly in an email, and so we really need those to be very understandable. People need to see, what am I being told here? What is the story behind the data? What is the data? And so we really need to make sure that we keep our visuals simple. And so that's a big point of advice that you'll see recurring throughout this talk is simplicity is your friend when you're doing visual analysis, right? We need to remember that our audience needs to understand what we're presenting. They might be monitoring the data. They might not have a lot of time to analyze. Keep the visual simple and focus on the data. The final point I'll make about what makes a view effective is that it needs to be interpretable, right? I need to be able to look at it and understand exactly what the data being shown is, what the encodings are. And so here's a graphic from the New York Times that does a great job of annotation and use of legends and titles and captions to tell me exactly what's going on here. This is the San Diego wildfires from a couple years ago. And they have a nice use of a legend, a nice use of annotations, nice use of context map to really help me understand what am I being told here and what are the factors driving this story. Now, having said that, this was designed for a large audience where we're not sure exactly the specific point that's relevant to each person, and it's designed for careful study. My advice in most cases is annotate but remain focused. Make sure you annotate the key points in your data, but make sure also you annotate only the key points in your data, right? Most visuals can only effectively tell one story, and if we over-annotate, you can risk losing your audience's focus on the key points. So we've talked a little bit about how, or what is an effective view. Now, how does Tableau support generating effective views of data, right? We want people to engage in this rapid Q&A and use this incremental ability to build up views, so how do we make sure those views are effective? So there's a number of things we do, from limiting the visual properties to having great defaults to using small multiples. And I'm going to talk about several of these in depth to just really emphasize how they support the cycle of visual analysis and why that's important. So limiting the visual properties to a small unproven set, let me talk to that point first. Often I'm asked, why don't we include more encodings in Tableau? We could use orientation or more transparency or 3D or some other type of encoding. And the fact is it's actually really hard to use multiple encodings within a single visualization. And it's really hard to use them together. And so we actually limited ourselves to things like color, size, text, stuff that's been carefully studied where we know a lot about how to use it effectively and we know a lot about how to use it together effectively, so that as people are engaged with their data, they're not likely to generate poor visualizations because we've limited to the visual properties that are most effective. We've also used great defaults, and let me talk about that. Saying I'm going to focus on using color because our perceptual system is really effective at parallel processing coloring is one thing, but a second aspect is making sure the colors we use are effective, right? For colors to be effective, we really need them to be perceptually equivalent. And this is a really hard task, actually, to say, pick me a set of perceptually equivalent colors. In RGB, it's really a random scattering. It's really hard to go to the RGB color space, which is a common color space in computer graphics, and say, what are a number of perceptually equivalent colors? We can switch to a color space like hue, saturation, value, and then a line in hue, saturation, value almost corresponds to a set of perceptually equivalent colors, but not quite. And it turns out it's really hard pragmatically to pick those colors, and so what we did was we hired a world color expert to manually pick the colors, and then we built them into the application. And so here I show a couple of the palettes we use, and I want to make a couple of important points, right? If we look at this top palette, although we use a lot of colors, none of them really jumps out as more saturated or bright or dominant than the others. We really tried to make it so that the greens and the reds and the purples all felt equally important. We didn't want to accidentally draw attention to an aspect of the data if that wasn't the author's intent, right? For encoding numeric or ordered data, we use saturation and value. We use a color ramp like this, where it encodes the fact that there is this varying quantitative property of the data, and each of these colors is chosen to be, actually representative of the change in scale, much like we talked about before with size. We discourage use of more than 20 colors because it's very hard for people to talk and think and remember those colors. We also do subtle things, like we picked colors so that they're easily named and people can talk about them. Right? If you look at the Excel palette on the bottom of the slide, you can imagine being in a presentation having to say silly things like the cyan, pinkish, orange in the upper corner, when you really want to say, and as we can see, the blue line is trending up. Right? And if you look at the color palette we've built into Tableau, we can talk about blue and green and red and purple and brown and pink. Colors where everybody's very quickly able to understand which color you're talking about. We also made sure to build in colorblind palettes so that it's easy to generate views that are effective for the entire audience. And I really find the contrast here, if we compare Excel XP and Tableau, you can really see the difference in the subtleties of picking effective colors. Another important point is we actually have two separate color palettes in Tableau. There's a palette for communicating data, and then there's a palette for aesthetics, for things like shading headers and reference lines and logos and everything. And we made sure to actually pick two different palettes, one which was more focused and drew attention to the data and focused on aspects like the importance of the data, and the other which is designed to be complementary but not overwhelming to that data, because we want the focus to be the data, not the formatting. And then we have different palettes for areas and lines, because a reference line needs a dark color, whereas an area needs a much lighter color, since as color spread over area it becomes more perceptually saturated. We do other things in the application, like using automatic marks to pick the best mark based on the data. So you'll notice as we go through and create graphics in Tableau, we don't say line chart, then bar chart, then scatter plot. We just start dropping fields on the different shelves, and our mark type is picked automatically for us, our color palettes are picked for us. We can always override this, but we try to incorporate best practices so the users don't have to think about it too much. And for example, here we can see, when we dropped year on columns, the system automatically picked a line chart, because looking at time, lines are very effective. But when we dropped an ordinal or a nominal category like market segment, bars were picked, because that is you can't interpolate between market segments, and therefore a bar is a much better practice for displaying the data. As I mentioned before, it's really hard to use more than a couple encodings simultaneously. It's hard to use color and size at the same time and have people really able to look at the data and quickly understand what's being told. You're really limited in the number of dimensions you can encode in color, size, and shape. But there's this amazingly powerful dimension that can be used over and over, and that's space or positioning. And one of the most effective ways to use it is tables, small multiples. Edward Tufte does a great job of describing this in his books. And here I have an example of a small multiple table where we've actually encoded a lot of dimensionality into this graphic, yet the graphic appears very visually simple, right? The table structure shows us products and markets and particular product types within products. And so now we can look at things like the red point within espresso in the east, and not only can we see that data, but we can see that data in the context of all other region sales of espresso and all other products within the region. So we have the multidimensional context, yet we have the simple graphics. And this leads to an important point is I've talked about keeping your visuals simple and understandable. That doesn't mean that you can't show a lot of data, and it doesn't mean you can't show a lot of dimensions. What it does mean is you have to be careful about the tricks you use to show that dimensionality in that data. And one of the most effective tricks in your toolbox is small multiples. They're very effective for comparative analysis and very effective for encoding a large number of dimensions in a simple display. One of the final aspects of supporting sort of being one with your data is that software needs to be easy and simple to use. And what do we mean when we say easy to use? Well, actually, easy to use can mean a lot of things, right? For an airport kiosk, being easy to use means that I can walk up to it and get it right away. Whereas for tools that I'm going to be using every day, like analytics software, it's probably a lot more about efficiency and about supporting my task than it is about learnability. I think an interesting contrast here is that chart wizard is really easy to learn, but it's horribly inefficient and hard to use if you're actually trying to engage in the cycle of analysis. I can create a bar chart quite easily, but I can't quickly try different views of different data. And so there's this balance and ease of use between learnability and intuitiveness and efficiency and directness. So in Tableau, how do we achieve ease of use? Well, again, it's about being incremental. It's about being direct. It's also about providing freedom. Knowing and respecting a user, their task, and what they're trying to do. And again, being simple. So I talked about incremental and direct, so I'm not going to focus on those more, but let's talk about providing freedom. Right? Freedom is actually a company value for Tableau. It varies from, am I using templates or am I free to quickly change my data to, do I need a 6-month IT project to get up and running, or can I download those off the web, install, and answer questions today? And am I in modes or wizards, or can I just start asking questions of my data and get answers? And the reason I actually include that in this talk is because I want to also make the point to people publishing views, empower your audience, share interactive views. A huge aspect of freedom is the ability to, as a author or consumer of a view, to be able to quickly interrogate that data and change that view. Right? If I publish a chart to you and it's static, I may be able to tell you a story, but I can more effectively tell you a story if I publish a view that's interactive, and you can test my hypothesis, and you can tease the data, and you can validate your confidence in what I've told you, because I've empowered you to work with the data that is behind my conclusion. Knowing and respecting the user is also a really important aspect of designing software to support visual analytics. And this varies to focusing the interface on the content. Using the tool is not about the tool, it's about the data. It's about making sure we support the user task, which I've talked about a lot today. The task is visual analysis. It's not about creating a bar chart, it's about engaging in Q&A with the data. It's allowing the user to get into an uninterrupted flow, and it's about providing great defaults. So here, as an example, we spend a lot of time really focusing on making what is the most important aspect of the user experience, the data. Right? This is about engaging in Q&A with your data, about understanding your data and presenting your data. So we use, a single toolbar with a limited set of very muted buttons. It's often quite an argument about whether a feature gets a new toolbar button, because it may distract from the real importance, which is the data. We minimize the non-data ink. We tend to use unsaturated colors throughout the interface. So my advice is to take this same concept and apply it to the presentations and the data views you create. Make sure they stay focused on the data. It's very tempting to add, a lot of formatting and logos and images and stuff, but to the extent they detract from the story and the data, you're not adding value, but rather taking it away. So it's really important that views stay simple and focused on the data. The final point I want to talk about is generating beautiful results. It's important that we are able to find the stories in our data and engage in Q&A, and it's important that the views we create are effective and they leverage our human perceptual system. But there's always also an emotional aspect to working with data and convincing people of your point of view. And being able to generate beautiful results that catch their eye and engage them is also extremely important. And here I have a couple of views generated in Tableau, and although they're effective and they're very easy to construct, they're also beautiful. And if this top view here, so on the top here we have a view of our bug database of all things, and it's not something that should be beautiful, but I actually find it very aesthetic and beautiful and engaging, and yet it's also very effective, and it tells an important story. And on the bottom we have a map of the contributions data to the different campaigns instead of the expenditures that we were looking at earlier. And so the point here being that you can create effective views, but you can also create very emotionally engaging and beautiful results. So the thing I sort of want to end up with is, well, we've talked about the importance of visual analysis, and the question is, well, who is this visual analysis for? And I just want to make the emphasize the point that really visual analysis is for everybody who has data and just isn't getting the answers they need from that data. And so where this comes back to advice is, often I see a mistake being people look at visual analysis and say that's for the analyst in the corner, it's for the special project. But you shouldn't limit yourself to large data or special projects. I see a lot of people extremely successful with, they have 400 rows in Excel, which it turns out is really hard to understand. And they can quickly and effectively find different views that help them understand that data, gain confidence, and find its stories. Another piece of advice I want to give at the end here is to seek outside inspiration. One of the things I often run into when I'm talking to people is they want to get ideas of how should I look at my data. And this is often very specific to their task and their question and their particular vertical or industry. And so it's hard to just give them sort of a quick answer. And this is why actually one of the reasons we built the tool to allow you to quickly try different views, because really a lot of what it comes down to is trying a bunch of different views to find the views for your particular problem. But another important thing is to seek outside inspiration, right? We've been building our gallery on our website for this purpose, but what I've seen is often just looking at the New York Times or looking at our gallery or looking at other presentations, you can get a lot of ideas for effective visual analysis or visual presentation of your data. So I really encourage people to seek outside inspiration. A really great source of this is the books by Edward Tufte and Stephen Few. They present not only outside inspiration, but they provide guidelines and best practices that can really help you understand how to create effective views. So in summary, I just want to summarize the advice that I have for engaging in visual analysis or becoming one with your data. And really, the points I want to make are, you really want to iterate, explore, and experiment regardless of your task. Don't wait to engage in this cycle of visual analysis till you're looking for outliers. I mean, this is when you're trying to create the reports, when you're authoring reports, when you're gaining confidence in data, when you're trying to create a presentation. And remember to start your visuals simple. You can get started today creating any picture and then build up as you learn more about your data and its visual presentation. Remember to reverse your thinking, not start with how do I want to look at the data, but what do I want to ask of the data? What am I trying to understand, and then what are the best ways to look at it? Start with the data and then the view. And as you create the views, keep the visuals simple. Don't detract from your story. Your annotations and everything you add, make sure they're adding value to the message you're trying to create. Really, really leverage small multiples as an effective way to encode a lot of dimensions into your picture. Remember to empower your audience by sharing interactive views. Stay focused on the data, and again, don't limit yourself to large data, and take advantage of the outside inspiration. Thank you very much for listening, and I really appreciate your time, and I hope that I've been able to add some value through this talk. Thank you.